So now for example number 3, um, I want to remind everybody that when we label a triangle, and I know I keep saying it, but sometimes you guys kind of zone out, which causes me to have to repeat myself, and that's okay. My triangles are labeled capital A, capital B, capital C, and the side lengths corresponding to the capital letter angle are opposite. In other words, this is angle A, and side A is lowercase a, and it's opposite of A. B, lowercase b, is opposite of capital B. Lowercase c is opposite of capital C. And the actual law of sines, the last example that I did is not necessarily the law of sines, but it's an application um, of sine. This is the actual law of sine. So this is kind of a neat thing. There's a ratio because sine of capital A corresponds to the length. In other words, if I take my hands and I open up my hands to the angle A, obviously if I open my hands wider, the length of lowercase a will change if I close them, right? Does that make sense? So then there is a proportionality between sine of capital A and lowercase a. And that will be equal to sine of capital B over lowercase b. And then that would be equal to sine of capital C over lowercase c. Another way that you could write this, because these are ratios, you can also think of it like this: a over lowercase a over sine of capital A, and lowercase b over sine of capital B, and lowercase c over sine of capital C. So those are two variations of the actual law of sines. So this is the actual law of sines right there. Okay? So in example number 3, I have a triangle that's drawn like this, where this is A, this is C, this is B, and this is C. This would be lowercase a, which is equal to 20, and then opposite of capital B is lowercase b, which is equal to 11. And what we're asked to do is we're asked to solve for solve the triangle. Now when you're asked to solve a triangle, basically what you're going to do is you're going to find A, capital B, capital A, capital C, and then you're going to find lowercase a, lowercase b, and lowercase c. Alright? Actually, I drew those kind of close together. So I'm going to say lowercase a, lowercase b, and lowercase c. Alright? And my capital C looks a lot like my lowercase c. So these are all the angles, and these are all the sides. Now I'm given some of this information. Actually, I forgot to write this down, but the angle A is 115 degrees. Lowercase b is 11, and capital A, or I'm sorry, lowercase a is 20. So I need to find capital B, capital C, lowercase c. Okay? So now I can do this by using the law of sine. So I'm going to find lowercase c first. I know capital A and I know lowercase a, so I'm going to say A over sine of capital A is equal to C over sine of C. Now as I look at that, the problem is I don't know what the angle for C is. So this is probably not going to work. See, I was trying to find C, but I can't find C, so I'm going to have to take a different approach. Maybe I know this information, right? I know this and this. I could plug something in. The only other thing that I have is B. So I'm going to have to solve for sine of capital B. Now, as I look for this, I'm going to have sine of capital B on the top. So what I'm going to do is I'm going to write it this way and say sine of capital A all over lowercase a is equal to sine of capital B over lowercase b. Now, I did that on purpose because what that will allow me to do is when I go to solve, it just saves me an extra step. Anyways, let's just plug this in and chug it. So I've got sine of 115, oops, all over 20, which is a number, and that's equal to sine of capital B all over 11. Okay? So what I'm going to do is I'm going to take the sine of 115 divided by 20 and see what I get. So I just take my calculator out, and I'm going to say sine of 115 divided by 20. And I'm around to the fourth decimal place, so I've got 0, 1, 2, 3, 4. And so that's a 1, so I'm just going to round down to 0.0453 is equal to sine of B all over 11. Now, to get the 11 away from sine of B, I'm going to multiply both sides by 11. These 11s will cancel, and then I'm just going to multiply this number times 11. And I get 0.4985, so I'm going to 0.4985. So I'm just rounding that there. And sine of B equals this. Now, in order to find sine of B, what I need to do is I just need to take the arc sine on this side, and then the same thing over here. I'm going to say arc sine of capital B. The arc sine and sine cancel, so I get B equals arc sine of this number. So I'm just going to enter in my calculator. Second sine, that gives me the arc sine, 0.4985, close parentheses. And that gives me that the angle B is approximately 29.9 degrees. Okay, so over here I'm going to put 29.9 degrees. Now, what I can do on this particular problem is I can actually solve for C now, because A plus B plus C equals 180. So to find C, I'm just going to say 180 minus, in parentheses, 115 plus 29.9, close my parentheses, and I get 35.1 degrees. Now from there I can solve for lowercase c. So I got a little bit of room left over here. So I'm going to put, I love to go with the stuff that I know, so we're going to come back and revisit sine of A, actually lowercase a over sine of A, lowercase c over sine of C. So then that means I'm going to have 20 over sine of 115 is equal to C over sine of 35.1. So I'm going to say 20 divided by sine of 115. That'll give me a decimal, 22.067 5, no 6, is equal to C over, now let's do sine of 35. Let's see what sine of 35 is. Point 573, and then I have to round up. Okay, so now to get this 0.5736 away from C, I have to multiply it by 5736, and whatever I do on one side, I gotta do on the other. 0.5736. Oops, put that in the wrong spot. So I'm going to take this number and multiply it by 22.0676, and I get 12. In other words, this cancels with this, and I get C is equal to 12.7. So this is 12.7. So this right up here, this is my actual answer to the question. So what I did is I solved for this right here. And we call that solving the triangle, and we used law of sines to do that. So lowercase c was equal to 12.7. Angle B was equal to 29.9 degrees. And angle C was 35.1 degrees. So what we did is we solved, well, we were given this, solve for that, given this, solve for this, and given this, and solve for this. And we did that using the law of sines.